Part A, show that y squared minus 4y plus 7 is positive for all real values of y. So I'm going to complete the square. So I will have y minus 2 all squared, subtract 2 squared, plus the 7, simplifying that, and now I can see that the minimum value is 3, when y is equal to 2. Therefore, always greater than 3, or always greater than or equal to 3, so always positive. Bobby claims that e to the 3x is greater than or equal to e to the 2x, where x is a real number. Determine whether Bobby's claim is always true, sometimes true, or never true. Well, let's pick a value of x. What about when x is 1? Then we would have e to the 3 times 1 and e to the 3 times 2. And yes, e cubed is greater than e squared. So his claim is true in that situation. What about, let's pick a different value of x. Let's try and find one now where it's not true. What about when x is minus 1? Well, e to the minus 3 and e to the minus 2, and that's not true. E to the minus 3 is less than e to the minus 2, so Bobby's claim is not true in that case. So Bobby's claim is sometimes true. Elsa claims that for n being a positive integer, if n squared is even, then n must be even. We're going to use proof by contradiction to show that Elsa's claim is true. So I'm going to start by assuming the opposite. So I'm going to assume that if n squared is even, then n must be odd. Right, so if n is odd, I can say n is equal to 2k plus 1, which would mean that n squared would be 2k plus 1 squared, which would be 4k squared plus 4k plus 1. Now this is an odd number because I could write it as 2 times 2k squared plus 2k plus 1. This is odd, which is a contradiction because we started off by saying that n squared is even. This is a contradiction. If n squared is even, then n cannot be odd. Therefore, n must be even. Ying claims that the sum of two different irrational numbers is irrational. Determine whether Ying's claim is always true, sometimes true, or never true. So let's think of a couple of irrational numbers that we could add together. What about if I had root 2 plus root 3? Those are both irrational numbers, and when I add them together, this is irrational. So her claim is certainly sometimes true. Let's now think, can I come up with an example where it's not true? Can I think of two irrational numbers, when I add them together I actually get a rational number? Well, if I had root 2 and my other irrational number might be, for example, 1 minus root 2. This is an irrational number here. And crucially, when I add those together, I just get 1. And that's rational. So Ying's claim is sometimes true.